Hi and welcome. I'm Gideon. Today we are talking networking. My son Brian asked me a question about networking and said, Dad, I want to learn more about networking. So Brian is my son and we are joined today by him.
Hi, I'm Brian. I'm quite excited to learn some new things from my dad. I'm currently working in the cybersecurity industry. So yeah.
Doing some product support, hey Brian?
Yes.
Antivirus and product support.
Yes.
Okay, so I thought instead of us jumping into the complicated networking stuff, let's start off at the beginning. I believe that once you understand the fundamentals and the basics, then you set in a good place to go forward. So I've got some networking material that I've presented a couple of times at various places to give people a bit of an introduction to networking. So let's have a look at what we have here. So in terms of networking is, let's get out the way here. So we're going to talk a little bit about network basics, network switching, and network routing, because those three things are, switching and routing, are totally different. So let's have a look. What is a local area network? So a local area network is a network in a house. Brian, you've got Wi-Fi at home, and that's a local area network. So it's in a house. And when we move to wide area networks are when we take lots of premises or lots of houses and we connect them together through some other network. So normally companies have remote offices, etc. And connecting all of those together is a wide area network. In your place of work, you don't really use a wide area network other than the internet is really your wide area network.
Yes.
And you support using VPN?
Yes.
Okay. So a wide area network is just really a connectivity of lots of premises together. And we can secure that connectivity. And even that wide area network could be a private wide area network, or we could use the internet as a wide area network. But let's start off with LANs. So what is a LAN? So if you want to buy a LAN, you typically have got a subnet, and you build a LAN, you buy a switch, and you plug some wires in some holes that fit. So if you plug a computer into a switch, that little Wi-Fi router you got at home, you've created a LAN.
And then you can connect multiple different devices to the one LAN network.
Yes, and they can all talk to each other on a LAN. Okay, but now we can have a company, and a company can have 2 floors, for instance. And we can take 2 switches. The signaling on these things, the wires can only be so long. So typically these things started off with what we call 10 base T, which is those little plugs you plug in the back of your computer. And 10 base T was a 10 megahertz network. We don't use them anymore. We use 100 meg or gig or 10 gig networks. But there's typically holes in these switches. And if the cable fits in the hole, I always say to everyone, it's probably going to work. It's probably going to work. So you'll see that these switches, we've got 2 switches over here. And these switches have got different holes in. So typically the 48 ports, the holes marked with yellow, are one type of hole, and then those 4 ports on the right hand side are different types of holes. And we'll get into that later in the discussion about what switches are. So we can connect 2 switches together on a single LAN, and they will work quite happily. And when we got a switch, we got 2 types of ports. So when you plug a computer into the switch, we call that access port. And when you plug 2 switches together, we call that a trunk port. Okay. So it now becomes important. So how would the switch know what device is on what port? So a switch does switching, right? So switching works with MAC addresses. So every computer, cell phone, anything with the Ethernet interface or network interface gets what we call a MAC address. So these MAC addresses are typically got 6 octets. And the 6 octets, the first 3 identify the vendor and the last 3 identify the serial number of that specific device. So this gets put into the network card when the computer is manufactured. So when my Mac's manufactured, I get a network card in Mac, and that network card gets stamped with some other MAC address.
Okay.
And those MAC addresses are then used by the networking protocols for the switch to identify which computer is in which hole on the switch.
So each machine would have its own separate MAC address.
Every computer in the whole world has its own MAC address.
Okay.
So every laptop, every PC, everything has its own MAC address. And we can identify, based on those first 3 octets, who the vendor is. So Dell would have a certain number there. And you can actually look this up on the internet. You say MAC address vendor lookup, and you can go see what MAC address. So if you scan a network and you see MAC addresses, you can figure out sort of what type of devices those are. Lots of the laptops and things are using some Chinese manufacturer, and they use generic network cards. But the major manufacturers, Dell, HP, Cisco, have got proper vendor numbers, and we can identify those. Okay, so let's have a look over here. So I said we had different types of ports. So the 100 base T or 1000 base T or gigabit Ethernet ports are typically 100 meters long. So the wire is not allowed to be longer than 100 meters from the physical switch. So if you put the switch on the floor of your building or in the room of the house, the wire to the computer is not allowed to be longer than 100 meters. If you connect 2 switches together, it's also not allowed to be longer than 100 meters. But you see those things on the right hand side. We've got those small form factor pluggable SFPs or GBICs. Now what that is that the physical media we're going to use. So we're not going to use the normal Ethernet cable, Cat4, Cat5 cable. We're actually going to use a cable defined by the GBIC we plug into that hole. So you get GBICs at different speeds, and you get GBICs at different media. On the one on the left there, you'll see that yellow one is a normal RJ45 connector with a normal Ethernet cable. And the one on the right hand side has actually got 2 little small holes, which are actually fiber leads. So I can use the same physical SFP port on the switch, and depending on the GBIC I plug into the port, I can use a fiber cable which doesn't have the 100 meter limitation.
Okay.
So when we've got buildings on a campus, for instance, and you get 2 switches and you want to connect the 2 buildings together, you get a little thing with SFP, a switch with SFP ports. And on those SFP ports, we then plug in some fiber cables, and we can run that across a parking lot between the buildings.
Okay.
Okay. Those 2 other ports on the right hand side, those are normally out of band or OOB management ports. We plug them into a different network. If the rest of the switch breaks, then we can manage a switch out of band.
Okay.
Okay. So what's a virtual LAN? So let's say, for instance, we've got a situation that we've got a finance department and a HR department, and we want to keep the 2 departments totally separate on different LANs.
Okay.
So what we do is we go, and we don't want to buy a separate switch because these switches can get quite expensive. So what we do is we go buy a switch, and then we VLAN the switch. So we say the first 24 ports belong to HR, and the second 24 ports belong to finance. And then we've got 2 different VLANs, and it's as if they're 2 totally separate networks.
Yes.
And we can decide if we want those 2 networks to talk to each other, or if we don't want them to talk to each other. Now switching is all about knowing in a LAN, so in other words, in this case, in VLAN 10, all the computers plugged into VLAN 10, that those computers can all talk to each other. That's called switching.
Okay.
So they only use MAC addresses, and they only connect to each other based on MAC addresses. There's no IP involved yet. It's only MAC addresses. Those 6 octets MAC addresses that's stamped on by the manufacturer. So what if we want to connect the 2 totally separate networks together? So often this is done inside of a switch, but it can be done externally as well. And we use a technology called bridging. So bridging is where we can have 2 separate VLANs or 2 separate networks, like layer 2 networks. And we want to connect the 2 networks together, and then we use a bridge. And the bridge will then say, okay, these MAC addresses are on VLAN 10, these MAC addresses are on VLAN 20. And if this computer with this MAC address on VLAN 10 wants to talk to that computer on VLAN 20, the bridge will facilitate the forwarding of the packets between the two VLANs. Okay.
So is it only a bridge that can do that, or?
Only a bridge. A bridge does layer 2 bridging.
Okay.
So a switch switches everything on one VLAN. A bridge connects VLANs together at layer 2.
Okay. And then if you have multiple of these switches,
the uplinks, so you can have, it's a very good question. So what we can have is exactly this over here. So we've got multiple switches. The switches are connected with a tagged or trunk port, and on the trunk port we tag the VLANs. So the bridge in the switch, right, does these things called BDPU, broadcast data packet units or something. And these BDPU packets then communicate between the switches. And that trunk port, VLAN 10 can exist on the top switch and VLAN 10 on the bottom switch. And now the network's just extended. It's now just a bigger network. So a computer on the top switch on VLAN 10 can talk through bridging to a computer on VLAN 20, if we enable that, on switch 2. So really the two things are all connected. You could also have a third switch much further away, and instead of having the uplink just between two ports, we can use those SFP ports and have a switch 2 kilometers away. And VLAN 10 can be extended to that switch 2 kilometers away. So any port on the switch is a port, whether it's an uplink port or a normal switch port, access port. So we can have a normal ports, the normal RJ45 ports, all the SFP ports, but they're all just ports, really. Okay. So that's quite cool.
Yeah.
So why do you need IP? Because now you can connect all these things together. Because we got this length limitation.
Isn't that for security reasons as well?
No. So IP doesn't, switching won't scale to internet size.
Okay.
Although some people argue that. But in the 1980s, we then came along with IP. So what we've done is, they came along and there's really 5 layers. So the physical layer we spoke a little bit about, which is the physical cable. That fiber cable can work over a longer distance than the normal Ethernet cable, which is normally limited to 100 meters. If you go 10 gig, the new 10 gig switches and 10 gig cables, they really want to use fiber. But you can make them work on normal Ethernet cable, Cat6, Ethernet cable 6A. Normally you're not going to get 100 meters out of it. I think the spec says something like 75 meters or something. So it even gets shorter than 100 meters on 10 gig. But if you do fiber, that can be much further. Okay. So that's a physical layer. The data link layer is really the switching layer. Those are the MAC addresses that we've just spoken about. Okay. The networking layer is really where IP comes in place. The session layer is really TCP. So session layer is TCP, networking layer IP, data link layer is switching, and physical layer is a physical cable. And then the application sitting on top of TCP IP could be something like HTTP, which your browser uses. So when you type in http://www.cisco.com or google.com, you're working from the application layer. You will create a TCP packet on the session layer, which will create the IP packet on the network layer, which will create data link layers on a switching layer in the local building. Remember, switching is normally one premise, one site, one building. Where networking is really about wide area networks. Okay. And there we go. So the cabling, the switching, the routing, TCP, which is a session orientated protocol, we'll get into that, and UDP, which is non-session orientated, and then applications, example HTTP, exactly what I was talking about. So the routing basics. So when we move, we've now spoke about switching and what switching is about. Now we talk about routing basics. So IPv4 is where the internet is and where many organizations are. We'll get to IPv6 later. But IPv4, you have 2 parts to it. So every address has an IP address and a mask. An IP address should never exist on its own, it must always exist with a mask. So every computer will always have an IP address and a mask. And the IP address will consist of 4 octets. And the 4 octets is a number from 0, except the first one, which must be a 1, to 255.
Okay.
So in the IP address, any number between 1 and 255 in the 4 octets is valid. So 1.0.0.1 is a valid IP address. Okay. The mask then says which part of the IP address belongs to the network and which part of the IP address belongs to the hosts. So in this case, the 255s are marking the first 3 octets as being part of the network and the last octet is being part of the host. So in the last octet, in terms of IP addressing, you can now have 255 host addresses. Now normally what happens is the first one's gone and the last one's gone. So the .0 192.168.0.0 is normally the network address and we don't use that. And then the very last address, 192.168.0.255, is a broadcast address. Okay. So you always lose 2 addresses, the network and the broadcast, but everything in between are host addresses. So that IP address 192.168.0.1 can belong to some computer or some device on that network. It could be a router, it could be a firewall, it could be your laptop, and that would be very valid. Okay. So the mask word says which part of the address is masked to the network, and then the other bits are masked to the host. Okay, I'm not going to get into it. Gets a little more complicated because we can actually work down to a binary layer on this, but we'll get there. So very quickly, so as we had VLAN 10 and VLAN 20, and they were switched together through a bridge. If we move to an IP layer and we want to work at an IP level, then we can still connect the 2 networks together without bridging technology, but now we can use layer 3 routing technology. Okay, so we've got a network there. The network on VLAN 10 is 192.168.0 network, right? With the .1 being the host,
yes,
or the router's address in this case. And then the 192.168.1 network, which is VLAN 20, which is actually a totally different network. And to connect the 2 networks together via IP, we use a router. Okay.
Okay.
Cool. So, it's very possible to have 2 buildings. And these 2 buildings have 2 different IP ranges. And you've got a private network via a telco. Right, and you're going to route between those 2 networks via the telco, but you address the top building or premise on the 192.168.0 network, and you address the other network on 192.168.1. Okay.
Yes. So if they've got the same IP address, your laptop, for example, will not connect to the other switch because it's got.
Yeah, so I mean the concept is that the top building would have, remember these IP addresses are not put in by the manufacturers, it's stuff we dream up.
Okay.
Right, so when we design a network, we dream up the IP addresses we're going to give to different buildings or different places. And it's very important for companies to maintain that data properly. You know, to maintain a spreadsheet and say building A is the .192.168.0 network, building B is 192.168.1 network. There are special tools where one can IP asset management, because IPs now become assets to a company. So now we can actually have IP asset management software which goes and maintains the building name and the IP address and then uses funny protocols to dish out the IP addresses as computers are switched on. Okay, but I think the concept I want to share in this diagram is that it's very possible to have 2 buildings. One is maybe your house and the other one is your office. And your house has got a certain network range and the office has got a different network range. And now we connect through a telco or through the internet to the 2 networks, maybe with a VPN, and we're using these private addresses to connect these 2 networks together. But the big thing here is to identify that the top network is a different network from an addressing perspective than the bottom network.
Yes.
Okay, so that's it. That's Networking 101. So in summary, you've learned what switching is. You've learned that a switch has got different holes, different cables that you can plug into it. That cables have certain limitations on length and speed. And we learned a little bit about routing and that routing is separate from switching. Routing uses IP addresses that we dream up, and switching uses MAC addresses that we or that are imprinted during manufacturing. Cool. You learn a bit, Brian?
Yes, thank you so much.
Okay, so join us in Networking 102 as Brian and I continue our journey down the networking path. Thank you for joining. Click the subscribe button and click the like button. Thank you.